paper is about the unexpected discovery of a noble gas molecule in space. Unexpected because we don't normally expect an atom like argon, a noble gas, to form molecules. And also unexpected because the place where we found it was in a supernova remnant, the Crab Nebula, which was the remnant of an exploded massive star. The first part of our observational program with Herschel was to image the Crab Nebula in the far infrared, because the continuum emission that comes from the Crab Nebula is dominated by newly formed dust grains. The prime goal of our program was to measure the amount of dust that young supernovae remnants had created, because we now think that supernovae may be one of the main sources of dust in the universe. And the Earth that we live on, the stuff we are made of, came from dust particles that formed around evolved stars, and it seems formed in the explosion of supernovae. So what we wanted to do in our program was work out exactly how much material, how much mass of dust that supernovae were creating in their explosions. That was the prime goal. That's why we took the images, and we found that the Crab Nebula had created nearly a quarter of the mass of the Sun of dust particles, several 100,000 Earth masses of dust. A follow-up part of the program was then to take spectra, look for molecules that were also associated with the dust formation. And when we took the spectra of the Crab Nebula, then we saw these very unusual features, which took us a while to work out exactly what they were. And it's in that part of the program that we discovered this new molecule. The famous Hubble Space Telescope images are a combination of different emission lines, some of which are from hydrogen, some from helium, some from oxygen, nitrogen, and even argon. Now, the interesting thing about the fact that these argon has ionized species in the ionized gas, and they're giving us emission lines, we can tell that there's plenty of argon in the Crab Nebula, but we didn't know what isotope it was, because the optical emission lines and the visual don't bear the signature of the isotope that they come from. It's only when you go to the infrared that you can see vibrational or rotational splittings of the different isotopic species. So that's what Herschel could do for us. It's interesting that this first detection of a noble gas molecule in space is one containing argon, because the very first detection of argon on Earth was carried out at UCL by William Ramsay in about 1900. What he did was he liquefied successive fractions of air, and at different freezing points, different atoms and molecules would condense out. And first of all, you get rid of nitrogen and oxygen. The next most abundant species turned out to be argon-40. And he went on beyond that to determine and isolate many more noble gases: neon, krypton, xenon, radon, and helium.